Okay, hello. So tonight here is 8, it's 15 past 8 p.m. Still not very dark, so it's a bit it's sunset time. So now I'm going to show you what I'm doing at the moment, and this is a course on edX, and this course is released by Harvard, and it is about statistics and R. Here is my R Studio Cloud, and I use this to store it on all my projects I'm working on. And here is the project for this course, Statistics and R for Harvard. So I'm going to open this. Now you just be bumped inside an already started course. But this is a very important part of the course because it's the central limit theorem. The central limit theorem is very important in statistics and in data analysis in general because it makes comparison of the averages. So let's say, for example, we have two sets of data, x and y, and we make the average of this data, and then we project two samples, one for x and one for y, to calculate the averages, and this that would be the forecasted value, so most probably value that will represent a sort of forecasted description of our two sets of data. So I have been doing this with using our Studio Cloud because it's very useful. I don't need to download anything. I suppose that you already a knowledge about R for this video. So I open a new script and save it and name it like Central Theorem Exercises. And then I do the same here just to have a bit of reference about what I'm doing. So the exercise for this central limit theorem are so we need to use this data set. So I'm going to copy this down on this side. And these few lines are supposed you know what are they, but basically just very roughly they are useful to download the data we are required to analyze. And in this case, the data is a mice phenomenon. We are going to analyze a study about mice, and we see what we are required to do. So I'm gonna control enter and load all the data. Now I have named my data set DAT. I have just eliminated, cancelled, omitted all the nav values because I suppose I don't need it for this exercise. So I'm going to practice this this theorem and doing this exercise. It says, okay, it says, if a list of numbers has a distribution that is well approximated by the normal distribution, what proportion of these numbers are within one standard deviation away from the list's averages? So the central limit theorem it tells us that the sample average follows a normal distribution. So we want the proportion of these numbers that are within one standard deviation away from the least average. So we use P norm, as the suggestion said, to use. So P norm 1 minus P norm minus 1. And this number 0.6826 etc. Is the deviation of one standard deviation. And then we check the solution, and this is the solution P norm 1 minus P norm. We save the answer and we go forward. Then we do the second exercise, which asks exactly the same, just it changes the saying that what proportion of this number are within two standard deviations away from the least average. So P norm 2 minus P norm minus 2. So this is the result. We can take this number and just put it here. Save the answer, show the answer, and that's again. Now it asks for 3. So we go forward saying that the proportion with 3 standard deviations away from the least average is P norm 3 minus P norm minus 3. And then we see these 3 numbers, how they differ from each other. And the meaning of this is just that a deviation away, a deviation from one standard deviation is nearly 70%. 2 standard deviation is 95. 3 standard deviation is nearly 100%. So obviously there is a increase in distance if we do increase the standard deviation. So now we go forward and say what is the central limit, what does within our data set. And this is the scope of the fourth exercise. define y to be the weights of males on the control diet, because our at the beginning we have loaded a data set which is made of mice and they weights following a different diet. So we just need to see what this data do, and then check about what is the proportion of mice within one standard deviation away from the average weight. So in this case, we do first y, which is they are our male. Let's do first head dat to just have a quick check of the data. They're made of three columns: sex, diet, and body weight. So these mice are female and male with high fat food or controlled diet. And this data set is that we can even check the dimension of that. The 3 columns and 841 mice. Some of them are female, some of them are male. So we now want just the male proportion. To do this selection, we do that and then pipe. So we restrict the data set just to filter sex by male. And then for diet, we want the control diet. So diet, we want the control diet in this control weight. Okay, because I knew the data set, so it's maybe better to see what is this diet and have a quick look saying that and diet. So we have some with high fat food and some with control diet, on control diet. So we need show and then again pipe, and I need to do dplyr this way because I have Magritte and otherwise select command doesn't work. And then what I want is the weight. So as you see, the third column is made of body weights. So I have body weights, and then again pipe and unlist. So this way I obtain a list of numbers that I will be able to use when calculating the mean. In fact, if I do y and see how it is, it's body weight just for male